co-coordinated by the European Commission together with European Schoolnet and MC Communication Agency in Berlin. So as a part of this initiative, we're running the Code Week MOOC, where we want to help teachers develop competencies and skills and get knowledge to integrate coding and computational thinking into the classroom. And as a part of this MOOC, which is running through October, until the end of October, we are running 3 live events. We hosted the webinar on the 1st of October. I hope that some of you were there and attended. If not, you have all the information in the live event page. We also had a very lively and lovely Twitter chat last Saturday, and this is the 3rd and last live event, which is at Teachmeet. And so today, as a part of the Teachmeet, you're going to hear from 9 different teachers from all over Europe that are going to tell us how they live Code Week themselves, and how they integrate coding and computational thinking into the classroom. So I'm very much looking forward to hearing from your presentations. I'm losing the presentation. Alexandra, is it you moving the pod?
No, I'm not doing anything. Everyone should be aware of not going around clicking things.
So please, everyone, now that we have everybody with presenter rights, I'm going to ask you kindly to not move your mouses unless you're presenting. So don't move your mouse unless you're presenting. Thank you very much. And again, sorry for the technical issues. So that's okay. Happen again. What's happening? Please don't move your mouses. Okay. Well, we'll make do. So thank you very much again, and thank you for your patience. Without further ado, I'm going to give the word to Alexandra, who is going to tell you a bit more about the speakers and is going to run by the agenda and let you know how this is going to work today. So Alexandra, the floor is yours.
Yes, thank you, Eugenia. Thanks, everybody. For today, I would like to tell you some things about the structure of this live event, and furthermore, I will introduce the speakers. So, how we have structured this live event. We have 9 inspiring speakers with us today that I'm going to introduce to you right after. After each presentation, 1 quick question will follow. And as soon as all speakers have finished, there would be some time for a Q&A and a discussion. So I would like to say to everybody that if they have questions, please write them on the public chat, and then we will raise them up at the end. If everything is clear so far, I would like to introduce our speakers. I hope everything is clear.
Yes, I would like to add, Alexandra, please ask questions during the presentation as well, because after each presentation, we're going to ask 1 question to the speakers, if that's all right with you, speakers. So please don't wait till the end to ask your questions. Do it type them on the chat, again on the chat, while the presentation is ongoing, so that we may pick 1 question at the end of each presentation.
Yep, great. That's why we have the public chat, so that can everybody share their thoughts and their comments and their questions. So our first speaker for today is Leticia Gil from Spain. Then we have Athanasias Zafiropoulou from Greece, Suhit Bhattacharya from the UK, Emma Badi from Italy, Maya Machinko from Croatia, Katerina Spica from Greece, Costanza Brevini from Italy, and last but not least, we have Javier Redondas from Spain. We can, if we are all ready and if everything is clear, we can give the floor to our first speaker, Leticia. Leticia, if you're ready, we are all ears.
Thank you so much, Alexandra and Eugenia. Can you hear me properly, all of you? Yeah? Okay, so
yes.
Good afternoon. I'm Leticia Gil from Toledo, Spain. I teach in a public school here in Spain, and I'm pre-primary teacher. So I would like to explain to you in this webinar how's my experience coding with the youngest ones and how to introduce coding with them. Well, I think it's really important to start at the beginning, because our children are digital natives, and coding with them have a lot of benefits, such as they can develop new ways of thinking by breaking up the big steps into smaller ones, okay? And they can develop at the same time, take the fear out of making mistakes or failing, and it teaches persistence in finding a way to solve your problem. And young children learn best through play. So with this kind of exercise and activities I'm going to show to you in this presentation, you can see that our children are really, really happy and they can play all over the time, okay? Well, I think it's really important to include these kind of activities in the curriculum because we need to develop different crucial competences in our children related to computational thinking, such as problem solving or collaboration or analytical skills. What I normally do is to integrate all the areas and work on coding all these areas. So computational thinking can be taught across different disciplines. And children can interact and understand the technology that are around them. So learning coding at a young age helps to develop communication skills such as creativity or writing skills, language skills, confidence and perseverance, and they can develop and they can achieve different skills that they need to solve daily problems. And what activities I normally do with my students? Well, I prepare unplugged activities that without the necessity of using digital devices. You can see the pictures here. My students become robots and they need to follow instructions that other students give them. And another important activity we normally do is Cody and Robbie. That is a card game, and our students can play in pairs or alone. So they need a table and they need to follow instructions that the other children give them, okay? And, well, I don't know if you are watching the presentation, because I have no access. Can you see the presentation, the slide?
It seems that we're having problems with the presentation. I think Alexandra is uploading them now again.
Okay, thank you. Okay, thank you so much. So at the beginning,
so I think
don't
it's
worry.
on again, right?
I prepare and I program unplugged activities such as Cody and Robbie or different dances that they need to follow instructions. Easy instructions, because as you can see in the picture, if you use or if they play with Cody and Robbie, they need to follow easy instructions such as move forward or turn right or turn left. What's the problem? That when they are 3 or 4 years old, they don't know at the beginning what's their right hand and what's the left hand. So I normally create different stickers with color stickers just to know if they need to move to one side or another one. And another activities I normally do are related to Bebot and Dot. Both are robots that our children need to guide and to control. So they improve their concentration and motivation using them.
Not me.
What I normally do? Well, I create my own maps. As you can see in the picture, there is a map, a Europe map, because we normally develop different twinning projects, and I like to know that my students where all the European participants come from, and we normally use Bebot just to know where are the other participants. And the way I use is to create the map and to buy a transparent tablecloth that I divide in different squares, 15 by 15 centimeters squares, and you need to use it for all the maps that you can create. As I said before, we need to use we need to practice or to program different areas coding. So if you were learning letters or countries or wherever you want, or streets concepts, you can use your map and the table, the transparent tablecloth with the squares divided, just to program and work with all the areas. And Dot is a similar robot that moves following its instructions, such as move forward, turn right, and turn left. And what about the future? Well, I would like to continue coding, and I'm preparing a Scornabot just to continue coding with my students. And I would like to say that it's really important if you have the family support, because in my case, in September, I have the first meeting with them, and I explain to them how important and how many benefits have in our students use coding. Okay, so their support is really important. And that's all. If you have some questions, you can ask me in the chat or write me an email. So thank you so much.
Thank you very much, Leticia. That was very, very interesting. I have a question about your presentation. So you mentioned that you work with the Scornabots in the classroom.
Yeah, perfect.
And I was wondering, what do you think is why do you think we should work with robotics in the classroom? Why do you think it's a good thing for kids to work with robotics in the classroom? Why have you chosen the Scornabots, for example?
Yes, Scornabot, because I want to change, and because their motivation is really important, and they love playing with Bebot because they are really getting used to do it. But Scornabot is a new idea, a new innovation concept or object in class, and it's really important for them because, as I said, they are digital natives, and they can program this robot, and especially Scornabot can be built with them in class.
Right, that's true. It's something that you can do together and that you are learning as well as an educator, right? So it makes the process actually very engaging for everyone from both sides, actually. So indeed, it's actually a very good idea. Thank you, Leticia. That was very insightful and very interesting also to hear how we can implement robotics in the classroom. So thank you very much. And I would like now to give the word to Athanasia from Greece, who's going to tell us a bit more about how to integrate coding and computational thinking into the classroom. So Athanasia, the floor is yours.
Okay, first of all, can you hear me?
Yes, Athanasia, we can hear you clearly.
Okay, there is a presentation on the screen. We can see the last presentation of Leticia. Is that okay with everybody? Because I'm going to turn the slides. Okay?
Yes, you can move on.
Yeah.
Yeah, yes.
Okay. Good afternoon. I am an ICT teacher in Greece, and it is an honor and a pleasure for me to be among you, and I will share some ideas of collaborative coding activities. We had these activities in an e-twinning project. It is called Twist, and they are implemented with Microbit. I have some links to share in the chat. If I cannot manage to do it now, I will do it later. This is the link to project's working space, the twin space. I think that everybody knows Microbit. It is a microcontroller. It is half the size of a credit card and has an ARM Cortex processor and some sensors like thermometer, accelerometer, and magnetometer. It is connected through a USB port with our computer. It can be identified as a USB device, and we can create programs using an online environment. The online environment is makecode.microbit.org. These programs are in like blocks, but we can also go to a JavaScript environment. And after that, we can download the program to our device and run it. So what is this special about? Programming is not a collaborating activity, and we had figure out an activity for ice breaking using a microbit. We have asked our students to create their profiles in TwinSpace, just a description and an avatar for an image. We had a group photo, and we have uploaded this photo in a ThinkLink interactive image. Over each one of our students, we had a tag, and when clicking the tag, we could download the hex code, the program that was created in a microbit. This program was uploaded in microbit, and we could identify the name of our partner. Then the student could go to partner's profile and let a message to his profile. You can see the ThinkLink interactive photo here. I am giving the link to the chat. And we had also the opportunity to, instead of downloading the code, in case we have not a microbit, we have not the real thing, the hardware, we could use the simulator in the programming environment and run the project there. This is the second option we have used. Here you can see one of my students running the code and writing a message to our partners. The second activity we had as a collaborative activity was to create teams. We have used the microbit as a disk, and when shaking microbit, we had LEDs showing what this shows. It was a random generator from 1 to 6. So each student had a result and could join one of our 6 teams to work in an activity we have scheduled for them. This code was shared among partners, and the activity was repeated from everyone of us. I'm sorry, but somebody has stopped sharing the presentation, so I have no presentation to show. I can describe the rest of them until somebody uploads the presentation again. The microbit is a very good microcontroller. It is very handy, very affordable, and can be used for basic programming concepts that can be very easily understood by our students, because they see each one of the commands to be executed on the hardware. They have the sense of the different types of inputs. We can have inputs on the microbit using 2 buttons or shaking the microbit, and we can see what is the difference. Each time they use a different way of input. Where is please, could you stop clicking on the presentation, because I cannot manage it. If all of us are interact with the PPT, nothing is happening. Anyway, the last use I had prepared to present here was a project using the microbit as a thermometer. We had uploaded the program to the microcontroller, and we have compared the thermocracy that we have from the device with the thermocracy we had using a trivial thermometer. It was different. The two results we had a difference, and we had to search for the error factors. What is really the thermocracy that the microbit shows, and how we could make a calibration to have a real result according to our environment. I'm a really huge fan of this device, and I suggest that you could very easily adapt it to your classes. Thank you.
Thank you very much, Athanasia, for this wonderful presentation. Short, but really, really valuable. Thank you very much. I would like to ask you something, because I think I really want to know more about the students' reaction and response on that project. Were they really interested to work on it? Did they face major difficulties, and how you tackled them? Did they remain motivated throughout the project? Can you please tell us more about their reaction?
They loved microbit. I have used it today also with my class to create some music. I have it right beside me.
Wow.
And we use it with a breadboard like this. We can use it without the breadboard, but I prefer having a breadboard to create easy circuits. Mm-hmm. And this is how they have the sense that the program is something that kids can control and can see the results immediately on the device. Because sometimes we think that coding is drawing or making presentations. Scratch is a wonderful tool, but makes a misconception, creates a misconception to our students. This is also a very easy environment, and students have direct results from the hardware, and that is why I prefer microbit.
That's great. That's great. Thank you. And I guess there is a collaborative environment in classrooms so that they can deal with problems all together, discuss about them, because coding is not always easy, right?
Yes, you can download the project and you can share it to your partners, and they can adapt it is like remixing in Scratch. They can change the code.
That's awesome. Thank you very much, Athanasia.
Thank you.
And now we would like to give the floor to
Annie. Annie is next. I'm afraid to click on the slides because probably many people are doing that at the same time. So let's leave Annie do that for us.
I don't know. Hi, I'm on slide 24 now. I don't know if you can see it. I can. I'm Annie from Sweden, and I'm a teacher working for the municipality of Malmö, the third biggest city in Sweden. And right now I'm supporting, educating, and teachers in Malmö to work with coding, programming, and computational thinking, in a wide range. And we've taken the EU code beat as a way of putting a magnifying glass of our work, what we're doing when it comes to computational thinking and programming. So because there's so many things that that students are working with, so many skills that they're working with and understandings that they're getting, when they work with coding, and us too, I think, as well, if we're not working with that before we became teachers, perhaps. But I think there are several benefits and skills, even outside of the curriculum, so to speak. Oh, I lost my slide. Have to find it. Sorry. So what I want to tell you was how we start working with coding without computers. So we start with like coding a friend and program your teacher, or maybe do a dance code for a friend or the class or something like that. You give instructions to each other. For instance, there's a lot of things to do. Oh, good. Next slide. On this slide, you can see different kinds of robots that we're working with to enhance the learning from the working with programming without computers. So we are trying a wide range of robots like Mindstorms, WeDo, Kudo, Ollies and Zeros, Q and Dash. You see them on the picture, and you can combine these in a very nice way, I think, to get this deeper understanding. I have half a minute. And then we also work with these robots, the Now robots, and we have a big project going on with a professional dancer and schools and kids that are coding Now robotics robots together, and they combine this knowledge and they share their coding with each other. That's very, very short what we're doing. That was my 3 minutes.
Thank you very much, Annie. That was very, very interesting to see another perspective into using robotics in the classroom. I was also very happy to hear that you're also working with together with other teachers in Malmo or
Both.
in the whole country as well. How
Yes,
do you organize
in
yourself?
Malmo and in Sweden, and also in other countries as well. That expand and enhance the learning for us, adults and students, I think.
Yeah, indeed, indeed. It creates a whole community. Thank you very much. That's great to hear. You can see Annie's contact details. And now I would like to give the floor to Sujit, who's going to tell us a bit more about how to implement coding and computational thinking into the classroom.
Okay, yeah, thank you. Good evening all. Can you hear me loud and clear? Am I loud and clear? Okay, good. And also, can you see my presentation which says Sujit Bhattacharya, United Kingdom? Yeah, okay, thank you. So today, thank you for this opportunity. I just wanted to share it with you. You have already seen what the BBC microbit is, and I'll talk a bit more on BBC microbit because that is one of the things that we have been working since 2015. We have been working on this microbit, and we have trained more than 500 to 600 students in terms of this microbit. So this microbit, just 1 minute, I'll go back to this. So it has a lot of sensors. There are a lot of sensors which are packed in the microbit. So the microbit is a small microcomputer. It's a handle computer, a microcontroller, in fact, and it is connected well with the PC, and the platform and the hardware platform is such that it has so much sensor that you don't have to really connect any other external sensor to it to start with. But it has a provision to connect other external sensors through the golden connector which is at the bottom. So I was very excited with this version 1, and just 2 days back we have version 2. And so one of your presenters did talk about connecting the microbit with the speaker to generate music. But the microbit version 2 has a speaker and also has a microphone in it. So it's a very good news. We are all excited with this new launch of BBC microbit version 2, which will be released in November. The announcement is already done. And what we can do with this small microcontroller embedded with the sensors is that it not only can do small projects, but you can bring in a lot of science kind of knowledge to do experiments with microbit. I'll quickly show you one quick, very good example. And this is a platform. So the platform is a make code from the Microsoft, or you can work in the block like in Scratch, where it is very useful for kids who are 7 years old, 6 years old. They can work with the Scratch kind of thing. Just give me 1 minute. Don't move the slide, please. I'll move the slides. Don't move the slides. So this make code also has a very important feature of getting the data. On the bottom left I have shown, you can plot the data, you can get the real-time data coming in from the external sensors or the sensors which are internal to it. You can get and plot it on the microbit in the software itself. So what is happening? The physical microbit, whatever signal that it has, it is capturing, whatever analog signal that it is capturing, you can easily display it on the screen and see how the waveform is behaving. Right? So the next one very simple example that I want to talk about is that the microbit has a very small screen in front of it. This is the screen of the microbit, and this screen can also act like a light sensor. So what do you mean by light sensor? It means that it can detect the light. So just give me 1 second, please don't move the slides, please don't please move the slides. So this light sensor can measure the intensity of the light. So it can know when it is dark and when it is bright light. Okay, so what we can do, we can build a lot of projects like automatic street light, you can do magic candle, you can do a detection with the light for burglar alarm, and a lot of things can be done with just one sensor coupled with other sensors, like there is a radio communication that can take place between 2 microbits, so we can use the radio plus the light sensor to make a new project. So there is a lot of opportunity for us to do this kind of projects. So what I have done is that I'm just trying to show you that whenever we try to build such a system on the microbit or any platform, Arduino, Raspberry Pi, any platform, it is basically that we engineers, we are trying to mimic the human system. Right? What is a human system? We have sensors, like we have 5 sensors. We pass all this information to our brain, and then our brain processes this information, and we give the information to our actuator, the muscles and other thing to move. Right? Similarly, what we are trying to do in the artificial system is to create sensors, right? The sensors which will mimic the human sensors. Say probably like for the eyes, you can have a camera. For anything which can detect sound, it can be a microphone. We can have a speaker to give the output, which is an actuator kind of thing. So we can get all the information from different sensors, and then we can pass it on to the brain of the computer, which is a microbit in this case, and the microbit can give some output, which could be, in this case, I'm trying to use a light sensor, which is a LED, and pass it the information to the microbit, and then the microbit can raise an alarm. So for example, if I want to make a morning alarm, I can do that. But this is not limited. The experiments that we devise around microbit need not be limited to what the sensors in the microbit can do. We can extend the platform to teach them about the light. So for example, I was talking to them about the visible light, like we had a beautiful rainbow which has come up today, and then I talked about the different colors in the rainbow. But at the same time, we know that these are the colors which are visible to our human eye. But there can be an artificial sensor which can detect the ultraviolet. There can be a sensor which can detect the infrared. Like infrared, a classical example could be a remote control. Anyone, all of you, if you can go and point your remote control to the screen, to the camera, you can see the light coming out. And this light, it's not visible to your naked eyes. It is only visible through the camera. And also, you can also capture the ultraviolet rays through this ultraviolet beads, which you can get it from anywhere, very cheap kind of thing. So what is happening is that this microbit is not only giving a platform to do experiments, but it also trying to bring science into it. You can design a whole curriculum related to some topic in microbit. And not only that, you can do a small projects around science and engineering in microbit. You can also do Internet of Things. You can use this microbit to transfer the data to the cloud and bring it back to your dashboard kind of thing. So what can happen is that even during the lockdown, we have a huge opportunity of all the kids working at home, right, and doing a collaborative project through this IoT concept. So if you want to have more, if you want to know more information, I'm always there. You can note down my email ID. You can get connected with me through the LinkedIn, and I'll be more than happy to work with any teacher, parents, or the students. My background is more into space and defense engineering kind of thing. So I'm very happy to have more number of students in STEM, science, technology, engineering, maths. And I think I had a small demonstration, but because of lack of time, I will not show the demonstration right now, but you are most welcome to get connected with me. Thank you so much.
Thank you, Suhit. Thank you very much for the presentation. You transmitted your passion about artificial intelligence and coding to us really easily with your ideas. I'm not sure if I got this information. How old are your students, Suhit?
Yeah, my students range from 7 years old to 16 years. See, this platform with the microbit, we can transform the remote control cars which are not working, right? I tell my students, don't throw away any electronics that you have. You can convert this remote control car into a remote control through the microbit. You can plug the microbit in to the remote control with a small driver board, and you can make the rover. So my students range from year 7 and it goes on till 16. The beauty of this microbit is the computation can be done in the Visual, which is a Scratch base. It can be done in JavaScript. It can also be done in MicroPython. So the concept of the engineering the coding can go in different stages. It can go in a visual kind of thing for a very small children. It can go to JavaScript. It can go to MicroPython. So you can do huge lot of experiments with a wide range of students.
Okay, great. You also have some feedback from our participants on the public chat that you can have a look. Let us, yes, Suhit is demonstrating his work. Really, thank you for that. Let us now move on to the next presenter, who is Emma from Italy. Emma, the stage is yours.
Yes. Thank you. Thank you. Hello to everybody. My name is Emma. I'm teaching in a high school in Italy. My students are 14, 15 years old. The title of my presentation is an example of coding with App Inventor 2 for teaching sustainability and nature-based solution. I start from nature-based solutions definitions. You can find a lot of resources about this in European community websites. I just put the link in the chat for everyone. You talk about nature-based solutions when you try to find a good solutions for problem about environment and climate change and sustainability. I'm a geography teacher, that's why. I also like ICT anyway. In particular, in this slide, you can find the different aims, objectives of nature-based solutions. We are working as a classroom on nature-based solutions for increasing the sustainability of the use of matter and energy. My interest for these applications was born when I saw for accident an article on a newspaper about this Indian boy, Arun Kumar, that was just 12 years old, but he has invented an application to allow to his parents to track the bus route from the school, because he took the bus, but the schedule was not so reliable, and the parents were very worried and anxious, as everyone is parents is, and so he invented with App Inventor this very useful app to allow his parents to control where he was on the bus or not. This application, sorry, someone has moved, is called App Inventor. It is from Massachusetts Institute of Technology, the Boston Institute of Technology. It was invented by a Google worker, and now belongs to Massachusetts Institute. It's a very intuitive application. It's a visual programming environment that allows everyone, also children, to build fully functional apps. It's a block-based tool such as Scratch. That's why I define it a sort of big brother or a sort of older brother of Scratch. And in Italy, many students are used to use Scratch also in the middle school, also where they are very young in the primary school, and so it's very easy to introduce App Inventor because the system is the same. In this case, just you have to it's a cloud-based service that you can access by a Google, a Gmail address. And you basically have two parts. It's divided in two parts. You work with App Inventor Design and App Inventor Box Editor. You select components that are pieces that do actions for you, such as, for example, label, sound, button. Then with App Inventor blocks, you combine, you can assemble the various blocks that explain how components should behave. You connect this application with an Android mobile, and you can create everything. It's a very every app you can imagine: games, informational apps, personal convenience apps, apps to communicate. In this case, with my classroom, I'm going to finish. We are working with an application, a very simple application to make a quiz on sustainability. The task was create a quiz game with App Inventor aimed at helping the user to acquire information on a virtual sustainable behavior to adopt in everyday life, such as, for example, reducing home electricity consumption or water waste. I suggest to start with a quiz because it's very easy. There are lots of tutorials online, but it's very easy for students to create a quiz with App Inventor, also for students that are new with programming, with coding. And in this case, you can see in English, because my subject is taught in English, geography is taught in English. You can see the questions of the quiz the students prepared as an application to inspire virtuous behaviors towards sustainability and reducing domestic energy consumption. That's all. Thank you to everybody. I hope I was fast. I know, but also I hope clear. Of course, it's a totally free application, and it's very easy to use, very intuitive. Also, children can use. If students already use the Scratch, it's better because they will advance very faster with the App Inventor. It's very easy to use, really.
Thank you very
Also
much.
for people who are not so nerd. Okay.
Indeed, because very often we have this idea that to create apps or to code, we need to have very deep knowledge. So I really love hearing your presentation, Emma, and to see that it's actually quite accessible to all the students, no matter the
It's very accessible. Some students of mine, very few, to be honest, were a little bit worried about coding. Most of them were already used to code, but very, very little numbers. But it was very easy for them to be introduced in this application, and is a good way also for peer tutoring. I suggest you to let the most expert students to be the tutors of the other students, because it's a good way for peer learning in the classroom.
Indeed, that's a great idea. That's also a great idea to create a good atmosphere in the classroom and to let other students teach the rest. So that's a great idea. Thank you very much, Emma. That
Thank
was
you so
very, very
much.
interesting. I would like now, thank you. I would like now to give the floor to Maya.
Hello.
I see you and I hear you. The floor is yours.
So my name is Maya Machinko. I'm coming from elementary school Ivan Cankar in Zagreb, it's the capital city of Croatia. And I actually teach technology in the grades 5 to 8, so it would be kids 10 to 14. But since I am also a STEM ambassador in my country and I do a lot of after workshops, I decided to show you something else. It's a workshop called Encoding Mars for my kids that are aged 8 and 9 years old. So it's the 3rd grade in Croatian primary school, and most of them are 8 or 9 years. So I was thinking a lot about this Code Week event, and I decided to combine 2 activities. The first one is coding, and the second one is World Space Week, which is going on right now also. So we made something called Astro Documentary. My kids started downloading. It's called an application. It's called NASA Selfie application, in which we took selfies all around our classroom. We can decide the background photo. After all the kids took their background photo, we Googled a little bit, we did some project work, so everybody had to write some few sentences and discover something about the beauties of the universe on the photo that is behind them. The next step was the real coding, and the funny thing is that the coding we did has only 3 lines of code, so it's really coding for everyone. And in that moment, we used our background photos in the back and we recorded a sound. So every kid recorded like 4 or 5 sentences of sound and then said something about the universe. We put it between the stings, we put it 1 second of the pause, and in the end, we combined all the photos and all the sounds in one movie. So it was a really fun and playing activity. We usually call it now tinkering popularly, and it was really, really fun because all of my kids, first of all, they learned a lot about the universe, a lot about astronomy. They learned how to use elementary coding in Scratch, which they didn't use before. And they learned how to make a movie. So we talked about protection on the internet. In the end, we published our movie on Vimeo and on school webpage, and we could show them to the parents, to the friends, and to all other kids around. So this is how it looked like. We used the coding. They were so exciting, and in the end, I gave them diplomas with their name, and the kids was so in love. So they asked me, what's next when we are going to code something else? Can we do something more? And the best thing, it was so inspirational for them. So next time with their teacher, because I'm not like actually their real teacher, I just visit them sometimes, they made another movie and they sent it to all other schools in Croatia which wanted to participate in our project of twinning. So they shared and they learned a lot. So this is the kids in the end, and this is our diploma, and it was really, really fun. And if you have any question, I'm really willing to share, but my experience says that sometimes like 3 lines of code can be enough for motivate other kids to start exploring. And after that, I have like a robotics class. So I have 5 kids from that class that asked me they want to join my coding class, my robotics class. So now we are exploring more, and we're learning harder robotics because, I mean, I teach Arduino, I teach Lego and everything, but for small one, Scratch was a really good intro to start. So thank you, and if you have some ideas, questions you can ask, I can share a link to the activity, but it's really, really simple. So you just use 3 lines of code and everybody will love it.
Thank you very much, Maya, for this wonderful idea. It's true that your students seem really excited and enthusiastic in the photos. So I guess you will keep doing that the next years as well?
Yes, of course, definitely. We are repeating. We all actually have 2 more activities in our school, but after this, they already said we want to repeat it every year. So yeah, definitely.
That's really positive. And our participants also like the idea a lot. So thank you very much once again. I will now give the floor to Katerina, who is next. Katerina Spita from Greece. I can see you clearly. I hope, yes, I can hear you as well. So there you go. All yours.
I'm Katerina Spitza. I'm happy to be with you this evening. I'm a preschool teacher, and I would like to show you that coding is inevitable and very useful in preschool education. That is for everybody, and is feasible even without the use of internet or any robotic device. So let me start my presentation. At first, let's see why coding and why in preschool. Code is present in everyday life. Language is coding, mathematics is code, music, gestures, they're all code. Also in Greek preschool education curriculum, we need to develop skills like collaboration, critical thinking, problem solving, innovation, and these are all aspects of computational thinking. So I think that these can be easily done through coding. In our school, we use coding in everyday routine. This is an example. It's our door's code. Please stop changing my slide. Thank you. On each classroom door, there is a combination of small arrows showing different directions, and we also have 4 big buttons with arrows that shows left, right, up, and down. So each day, each student reads the code and the small arrows that at the bottom of the page, and then presses the buttons in order to enter the classroom. We also have codes in our weather timetable where we have replaced the weather conditions with sun. Another example is voice code. We use the book of a Great Let, a book of sounds, and we created a phonometer. We use the big and small circles of the book. Big ones represented the loud voice and small circles the low voice. We then replaced them with up and down arrows, and one student chose the arrows wanted to write on a board, and the rest of the class read the code by using low or loud voices. Then we became conductors and replaced the arrows with colors with the same way. We changed the arrows with colors, and we also added a horizontal line for pause. And again, the conductor wrote the code, and the rest of the students read them and used the loud voice or pause. We also created animal choir. We used the plastic animals from our classroom stories. We identified them with voice, and the conductor chose the animals, put them in a row, and the rest of the class made the voice of each animal and produced the code. We use coding every day with classroom stories. We create patterns, and students have to replace them and represent them with plastic colored balls, with Lego, with wooden sticks, with colored circles. We also played a game like Programmer and Robot. This can be done with anything in your class as long as you have 2 roles. One student plays the role of the programmer and the other student plays the role of the robot. The programmer takes a flashcard. We use the wooden, let me show you because someone changes the slide. We use the wooden shapes in our class and flashcards with animals. One was a programmer, took a flashcard, used words and phrases that show direction, and asked the student robot to choose the right shapes and place them in the correct spot. Then the flashcard was revealed after both students had finished, and then they evaluated their creation. This activity develops generally not only coding and computational thinking, but also collaboration, problem solving, vocabulary about directions, communication. These were some of the examples we used at school. Our school is a STEM school, so we try to use computational thinking and coding every day in everything we do. I hope I gave you some ideas and create your own ones. Thank you very much.
Thank you very much, Katerina. That was very interesting also to see how to implement games and gamification into the classroom, into a preschool classroom. So thank you very much. We have a question from Leticia. She's wondering about the arrows and the doors. How often do you change them?
Now we have the code from last year, because we have a lot of preschoolers that are 4 years old and would like first to learn about their orientation. We change them frequently, as long as they learn, because sometimes they learn the code by heart, so we have to change, and we change them every month, for example.
Every month. Yeah, that would make sense. Like, you make it also entertaining, right, for students, things change. Yeah, indeed.
Yes, we can see also in students when they play freely at the beginning of the day, they create robots, they write codes with their signs, and I think they enjoy it.
I'm sure they do. It sounds very interesting. Thank you very much, Katerina.
Thank you.
I would like now to give the floor to Constanza. Constanza, can you hear me?
Yes, I'm hearing. Can you see me?
Yes. Not yet, but I can hear you perfectly. Okay. It's loading now. Yes, perfectly.
Great. Okay, so good afternoon to everyone. I'm here to speak about what we do on digital media, which is a great concern of ours, since, as you can know, these kids this age spend a lot of time in online, mingling between the others with social media. And what we are really concerned about is to find. I can't control the slides. Can you help me with this? They're going up and down. They're by themselves. Okay, great. Thank you. So I was saying, we are working on digital media, meaning that our aim is, as we say, to find the creator at the end of the user, in the sense that everyone can be a user. The goal of a great software is just to be easy to use for a user. But what we want is for the kids to develop, for our pupils who are, in this case, aged from 15 to 17, we want them to be digital creator as well, not just digital user. Again, I can't find wait, because okay. I don't know what is going on, but everything is moving up and down. Okay, great. Here, great. Okay. So we started asking very simple questions like, what is a digital image? They really don't know what is a digital image. How do you make an image out of something, like just clicking a shutter? But what does that mean? So they know nothing about this. So we started from the very beginning, and we started introducing them to what is a LED, what is RGB code, what is the difference between RGB and CYMK. So just to introduce them to the problem and the solution that have been developed to solve this, how to display colors on our devices. Moreover, we tried to make them acquainted with what is a format. So what is the difference between the several formats they all knows, because all of them know what is a GIF, what is a PNG, what is a JPEG, but they don't really know what is the difference from a coding point of view, which is the important point of view, of course. And then one of the most interesting things that we have done with these kids is to help them build matrices, which are kind of sophisticated mathematical structures that are very well used in coding. And we make them build matrices so they can design their own images using bitmaps. and assign a value in RGB in this case, but also in other, there are also other languages that can be used. And then, lastly, we focused on the filters because we discovered that our kids were obsessed by filters, like always putting filters on their pictures. So we just want them to understand what is a filter in like deeply. The very deep meaning of a filter is, of course, in the code that someone wrote for it. So we tried to explain this and to make them design their own filters. I am done. Thank you very much. Thank you.
Thank you, Costanza, for this interesting presentation. If you could only mute your microphone, please, because I'm hearing my voice twice. Thank you very much. I would like to ask you a question because I didn't quite get if that's a course or a project. So I would like to know more about the duration of this project and more about the profile of the students, if you don't mind.
Hear you, Constanza. Can you unmute your microphone?
Yeah, sorry. This is a computer club that lasts 1 year, all year. So the kids that can enroll are kids from 15 to 17 years old. So that's the kind of students. And this is, but again, this is a computer club, so it's not mandatory. And it is something that kids with this kind of interest can do, also because, as you can see, it's kind of hands-on in the sense that they really, at the end of the course, they know how to program in Python regarding the PIL library. So just that library, but anyway, they can use them. They are very, very proficient in using that at the end of the day.
So since they wanted themselves to be there, I'm sure they are really interested and motivated to participate, right?
Definitely, definitely.
That's nice. That's nice. Thank you very much.
Thank you.
I will now give the floor to our last but not least presenter, who is Javier. Javier, if you are ready, we are ready to watch your video as well.
Okay. Hello, good afternoon. It is possible to see the video, I'm not sure.
Yeah, with all this confusion with the presentation, I'm afraid in this version of the presentation it's not there, but I will. Eugenia, will you do it or should I? Okay, yes. So it's uploading, it's being uploaded, Javier.
I will start to speak and to explain our
Sure,
experiment.
yes. Thank you very much.
Okay, I'm going to explain the experiment or activity we did with our students last year. I teach in a Spanish school in the northern coast of Spain. My students are from 13 to 17. And this activity was made with students of 15 years old. It was an activity called Space Mission. Right? What is a space mission? Space mission is an artifact we launched to the space. And really to the space? Of course, not to the outer space. We reach only what is called the near space. The near space is the stratosphere, is the upper part of the atmosphere. And 99% of the gases are below this level. So it's not a fair experiment like this, but I think is important because we involve the students in all the stages of the experiment. So what we did was to design a balloon and a payload. The balloons go to the stratosphere, it explodes, and it it lands again, and during the trip there is some sensors and some cameras and some GPS and all the electronic devices are recording information about the atmosphere. So the most important thing in this mission, this activity, was to demonstrate that it is possible, this kind of mission, in an educational environment. What is an educational environment? It means basically two things. One thing is low cost, and the other thing is not very high technical or scientific knowledge of the students involved in this project. Okay? So we have the aid, we have been assisted by a lot of institutions who collaborated with us in order to facilitate the things, like the University of the New University, who helped us with the communication systems, the Union of Radio Amateurs, also some local companies who make it possible to do some tests of the different devices, because in the stratosphere, for example, the temperature is around minus 60 degrees. So we have to ensure that all the electronic devices worked at this temperature. And how we did it? We went to a cryogenic chamber and we put all the electronics in this chamber and we test the performing of the system. Only 3 minutes, okay. The next step, this was the first mission, and the next step is to launch a second one, if this pandemic situation allows us to do it. And we would like to incorporate more experiments and maybe collaborations from other schools. I'm going to try to put the video in the point that we launch it. Here's the moment of launching. So, as I was telling, we would like to incorporate more experiments, and more experiments designed also by other schools. So, we would like to invite you to perform or to design some experiments which can be carried in our payload. Okay? This first mission, we only measure the temperature, humidity, and the pressure of the air. And we take these videos and some photos and nothing more else. Because one of the more complicated things was to recover the payload after landing. And this is basically all. So thank you.
Thank you very much, Javier. That was impressive and very, very amazing to see. I'm also very happy to see Asturias. I think it's as close as I will see my homeland in the next month. I'm very happy to see this video as well. Thank you very much. That was very interesting. I have a question for you, Javier. I see a lot of students in that patio when you launch the globe. Did you collaborate across several classrooms then with students of different ages?
Yes, most of the work has been done in a class of robotics, programming and robotics, where students from 15 years old, only a small part of the coding, precisely the recording of the data in the SD card. This is some quite complicated. It was done, but oldest students with 17 years old. And we also collaborated with another school, which is in León. León is it's more in the south of Spain, not in the south, but more south where our school is. And we launched our high altitude balloon from this school.
Wow, that's amazing. That's really, really impressive. So thank you very much, Javier. Thank you. That was very, very interesting. And that's the end of our presentations for today. We've been having a few questions throughout the presentations. If you have any more questions for the presenters, you can get in touch with them through the links that they have shared on the chat. We will also share with you the slides so you can take a look afterwards. And I would like to give the floor to Tommaso, who wants to say a few words to close this event. Tommaso.
Thank you. Can you hear me?
Yes, perfect.
Okay, great. No, my camera doesn't want to start. Sorry, but it's okay. And I'll let you also close the event afterwards. I just want to comment briefly and to thanks especially all the teachers that shared all such different, diverse, and impressive projects and activities with us. I think we all have witnessed in a way that there are so many applications, so many approaches, so many topics and subjects and elements that can be discovered and made more engaging also with coding. And the limit really remains the creativity of us as educators, as trainers, as teachers. So it's good. It's good because it makes us more and more convinced that what we are trying to do to achieve is meaningful, is worthy, and will lead to really better activities for our schools, for our students. I want also to thanks very much Eugenia and Alexandra for organizing and running the workshop. They had to face incredible technical issue. I'm really, really sorry for them, but they did a wonderful job keeping it together and making it work in the end. So congratulations and thank you so much. You put a lot of effort in organizing it, so it's a bit unfair that the system failed you, but very well done. It was a wonderful and very, very interesting Teachmeet, thanks to you and all the participants. So I'll let you say a few words as well to close down, and we'll see each other on the Deep Dive MOOC. Keep sending your questions and comments. And on Code Week, of course, which, by the way, doesn't end in October. Every week is Code Week, after all. But of course, this is when we celebrate the most. But stay with us before, during, and after Code Week as well. So I'll get the microphone back to you, Eugenia. Thanks a lot.
Thank you very much, Tommaso. Thank you for your kind words. And indeed, I would like to add to that big thank you to our presenters for these very interesting presentations. As Emma was saying right now, the variety of these presentations also shows us, the variety of things we can do with coding and the variety of ways in which we can integrate computational thinking into the classroom. So thank you very much for these very interesting presentations. I hope that to you participants, this has shown you a different way of doing coding and computational thinking. And I hope it has inspired you to create new things and to open up possibilities in your classroom and to bring innovation to your classroom, which is why we are all here, right? So thank you very much. Thank you also for your patience with these small technical issues. My apologies for that. But thank you very much. I think we've all learned a lot from the presenters. So again, a very big thank you. They have added their details on the chat. So if you want to get in touch with them or learn more about their projects, don't forget to check their chat. And as Tommaso was saying, every week is Code Week. We still have many more days of Code Week to run. So don't forget to add your activities on the map. Don't forget to get some inspiration from today and add your activities to the Code Week map. I saw that some people are having a few issues with the certificates and the course deadline. So if that is the case, please send us an email or get in touch with us. You can do so by clicking on the Behind the Course page, and you can see there the course coordinators. And if not, you can always send an email to the Academy, and they will be able to help you with any small issues that you have with the course. That being said, we still have 5 more days until the first course deadline comes up. So don't forget to register your activities in the Code Week map in order to meet the first deadline, which is 20th of October, to register your activities in the map. So I would also like for all of you that are here that are taking the course, to encourage you to finish the course and to meet those deadlines and to really take the most out of the course and get the certificate. So thank you very much to everyone. I would like now to close the event. Thank you as well to Alexandra for your support today, and thank you again to everyone today. So thank you very much. That's all for us for today. The recording will be available on the page, on the live events page of the MOOC, as well as the presentation where you can see everybody's photos and details and links. So again, thank you and have a very nice evening, everyone. That's all from us from Brussels. Bye-bye.